Good morning, my dear friends. See now let's go to another important loss. Loss due to creep of concrete. Okay, loss due to creep of concrete. See now, in sense again you have seen in your concrete technology what exactly this creep of concrete is. Okay, so now in sense now creep is a very peculiar characteristic of this concrete. What it does is, now as you know, Hooke's law. What Hooke's law says is, okay, stress is directly proportional to strain. Am I right? Now, stress is directly proportional to strain. So now, as you go on increasing the stress, or as you go on increasing the load on the structure, strain also goes on increasing. That is what the Hooke's law says. Okay, stress is directly proportional to strain. In the sense, as the stress increases, strain also increases. Okay, so now this is what usually this happens in almost all the materials. But now, in sense, but now what happens in case of your concrete is, well, even if you apply a constant load, even if you apply a constant stress, okay, the strain goes on increasing in concrete. This is the peculiar nature of your concrete. Okay, and this property we call it as creep. In the sense, say for example now, here is a column now. Assume that here is a column, okay, and I have applied some load. I have applied some load on it now. Okay, I have applied some load. So now in this column, okay, since I have applied a constant load, the strain should remain constant here now. Okay, stress is constant. Now strain also should remain constant. But it won't happen now. Now what happens? Under this constant stress, okay, the strain in this concrete inside goes on increasing. Okay, so this is what we call it as creep of concrete. In the sense, concrete shortens because of this creep effect. Okay, so now the same thing we shall now apply it to the precious concrete beams now. Okay, now you assume that it is a beam. Okay, you applied some load on this beam. So now as the time pass, so now this creep in the sense of this load which is now acting, it has got some stress. In a sense, because of this load, the beam has got some stress. Am I right now? So now what happens? The compressive stress is constant, but the strain inside it goes on increasing. Okay, compressive strain inside it goes on increasing. The result is the beam shortens by itself. When the beam shortens by itself, you know that the cable also shortens. When cable shortens, the loss of pre-stress will take place. Am I right now? That is how, now, the creep of concrete will result in loss of pre-stress. So now, according to your IS code, now, one simple equation is used to calculate the loss of pre-stress due to creep of concrete. Okay, loss of pre-stress due to creep of concrete is given by Cc minus 1 into m times Fc. Baba, you know that m is called modular ratio, and Fc is uh, the pre-stress, okay, in concrete, Fc, okay, and Cc is called creep coefficient. Cc is called creep coefficient. Baba, this creep coefficient can be taken as 2.5 to 3. Okay, any one value I can take it as this thing now. Cc can be taken as 2.5 to 3. Am I right, sir? Now, so that is how I can easily calculate the loss. Otherwise, now your IS code gives you another equation. Okay, in a sense, now it says that again the loss of pre-stress can be again calculated by another equation according to your IS code. It is given by epsilon Cr into Es into Fc. But now, whereas Es is, you know that it is the Young's modulus of steel. Okay, Fc is the stress in concrete. Okay, epsilon Cr means it is the ultimate creep strain. It is called ultimate creep strain, and this ultimate creep strain epsilon Cr is given by this complicated equation. Little bit it is complicated. Okay, sir. Now ultimate creep strain epsilon Cr is equal to 1.75 into 1.25 minus h divided by 0.25 into under root of 400 divided by fc into fc by fr into 10 to the power of minus 6. Its unit is centimeter per kg per centimeter square. In a sense, when you apply 1 kg per centimeter square as the stress, okay, stress, then this strain is centimeter per centimeter. Okay, so now here one term h is there. H is called, it is the average ambient humidity. It is the average ambient humidity in which the pre-stress concrete beam exists. Okay, so now usually h value will be given in the problem. Okay, no need to worry. And fr, here now something called fr is there. Okay, fr means it is the cube strength of concrete at the transfer of pre-stress. In the sense now, during the transfer of the pre-stress, okay, how much is the concrete strength? That is fr. And another one is there fc. Fc is here and fc is here. Fc means it is the cube strength of concrete at 28 days of curing. In the sense, after 28 days of curing, how much is the compressive strength? That is called, in a sense, it is the characteristic compressive strength. It is okay. It is nothing but it is the characteristic compressive strength fc. Okay, so now by using this epsilon cr value, okay, you calculate the epsilon cr value by using this, and then you can put it in this equation to calculate the loss of pre-stress due to creep. So sir, now this is how it can be now calculated. Okay, so now either you can use this equation or you can use another equation which we have seen, cc minus 1 into mfc. Okay, so by using both these equations you can calculate the loss of pre-stress due to creep of concrete. Also now, so now by using one equation I will demonstrate you the details. Okay, thank you very much.